Hello, yan. Meron na naman tayong new lesson dito sa differential calculus. So this will be our third lesson or third module ng ating differential calculus class. And we'll discuss yung importance ng continuity sa study natin ng differential calculus. So, bibigyan natin to ng isang buong session. Why? Kasi itong continuity, medyo simple lang siya. Relatively simple lang to. But then, it plays an important or a critical uh, role sa study natin ng calculus. So, that, we can say that yung limits, ito yung cornerstones ng calculus. And another cornerstone ng calculus is yung continuity. So, once na malaman natin or malaman ninyo kung anong ibig sabihin nito, mas mare-recognize nyo yung importance ng concept ng continuity dun sa mga succeeding works or succeeding work na sa calculus. So, yan. Let me start by yan. Let me start with the continuity at a point, di ba? So most people have non-mathematical sense of what it means for something to be continuous or not to be continuous. For example, uh, let's say merong intermission, merong orchestra or symphony na tumutugtog, then merong intermission. Okay? So masasabi natin na ito hindi to continuous kasi may mga musicians na nagte-take ng break kahit na tuloy-tuloy yung performance. Hindi yan katulad ng cycle ng araw at gabi. Yung cycle ng araw at gabi is essentially continuous. No? Dire-diretso yan. So, ganun din sa math. Yung common sense doon sa examples na binigay ko ng pag-aaral ng continuity, mas maiintindihan natin or mas matutulungan tayong malaman kung ang isang function ay continuous or hindi. But of course, we need to be able to approach a bit more formally. So, ito yung pag-aaralan natin ngayon. Kung paano natin ma, ma-identify kung continuous or hindi continuous ang isang function. Function by using yung limit. No? Pinag-aralan natin sa second part. So, we can say that a function is continuous at a given point, at a given point, if there is no kind of break, so walang putol, doon sa function at that particular point kung saan natin ini-specify. Okay? So kung ganito man, wala siyang putol, masasabi natin uh, na yung function na yan ay continuous at that point. Okay? Meron tayong tatlong components para masabi natin na ang isang function is continuous at a particular point. No? Ano-ano yung mga yan? Ito yan. So meron tayong tatlong conditions. A function f of x, okay? A function f of x yan, is said to be continuous at x is equal to c if these three conditions are satisfied. Number one, kailangan nag-exist yung limit ng function as x approaches that particular value c. No? So, kailangan may mag-exist yan. Okay? Second, dapat pag sinubstitute daw natin yung value ng c dun sa ating function, kailangan may mag-exist din siya. And third condition is that yung limit ng function as x approaches c should be equal dun sa f of c. Okay? So, Ngayon, if any or more, kung alin man dyan ang hindi mag-comply or hindi masatisfy, masasabi na agad natin na yung function is discontinuous at x is equal to c. C dapat to. Kasi C yung ginamit ko na example. Okay? So, subukan natin. Ano ba yung ibig niyang sabihin diyan? Okay? So, let me illustrate itong tatlong na to, tatlong conditions na to. Let us examine the function f of x equal to x squared plus 1. So, meron tayong function f x squared plus 1 at x equals 2. Okay? So, first condition daw natin, dapat yung limit daw nag-exist. The limit of f of x as x approaches c, dapat mag-exist yan. No? So, to check kung ganun nga, we will apply, therefore, the limit of quantity x squared plus 1 when x approaches 2. Diba? Yan yung ating domain. So, paano natin gagawin yan? Isa-substitute natin yung value ng 2 dun sa ating function. And it is equal to 2 squared plus 1, which is equal to 5. No? So, yung function natin, ang limit niya is 5. Therefore, the limit exists. Right? So, na-satisfy niya yung first condition. Second condition natin, ano ba yung second condition natin? Dapat daw yung f of c, dapat daw yan mag-exist. Exist. So, f of c dapat daw f of 2. Kasi ito yung c natin, no? F of 2 is equal to quantity 2x, sinasubstitute ko yung value dito. 2x plus 1, and it is equal to 5. Therefore, f of c exists. No? So, nasatisfy niya rin itong pangalawa. Pangatlo naman, sabi dyan, yan, the limit, yung limit daw na to, the limit of the function as x approaches c should be equal to f of c. Since nasagutan na natin kanina, di ba? The limit ng quantity x squared plus 1 as x approaches 2 is equal to 5, right? And it is also equal to f of 2, which is equal to 2 squared plus 1 equals 5. No? So, parehas naman equal yan. Therefore, the limit of f of x, ang pangit ng sulat ko, the limit as x approaches c of f of x is equal to f of c. O, di ba? So, ano masasabi natin pag nasatisfy ito? We can now say that f of x, right? F of x is equal to x squared plus 1 is continuous. Di ba? Continuous at x equals 2. Okay, so yan ang sagot natin. no? Okay? So, siguro mag-solve pa tayo ng isa pa. Isa pa. So, isa pa, ano pa tayo ng isa pa, no? Um, Let us examine f of x equal to square root of x. Para pinakamadali ano na. Okay? So, at x equal to 0. Okay? So, ganyan siya, no? So, sabi, first condition natin, testing natin, dapat daw yung limit ng function nag-exist. So, ang sabi, of the limit of the function f of x as x approaches c dapat daw mag-exist, di ba? Therefore, the limit as x approaches 0 of square root of x, di ba, is equal to, so paano natin gagawin yun? Um, Let us examine yung left and right hand, no? Yun yung pag mga ganitong equation or expression. Kasi mas ma-define natin kung talaga nag-exist yung limit ng isang function kung magkaparehas yung left and right hand side nila. No? So, wag muna natin sagutan yan. Sagutan muna natin ito. The limit as x approaches 0 from the left of x. That means we are going to substitute values dito sa x na mga negative, no? Therefore, lalabas sa atin dyan is the limit does not exist, di ba? Tapos, yan. Kasi magiging square root of negative eh, di ba? Kaya the limit does not exist. And then, pagka right naman, uh, the limit of the square root of x as x approaches 0 from the right. So ito, mga positive values ang ilalagay natin. So, meron tayong makukuha diyang limit na 0, no? So, the limit exists. So, yun yung first condition. So, second condition naman, ang sabi is dapat yung f of c, dapat daw yung f of c mag-exist. So, ano ba yung f of c natin? F of 0 is equal to the square root of 0. Therefore, it is equal to 0. So, f of c exists. No? So, nasatisfy niya to. Ito, question mark ha. Pag-usapan natin mamaya. Sa number 3 naman, dapat daw, yung limit, sabi, as x approaches the domain, no? That's c of f of x, dapat daw equal yan daw sa f of c. So, ang nakuha natin dito kanina sa right hand, no? Yung nakuha tayo dyan, x is 0 plus ng square root of x equal yan sa 0, and yung ating f of c naman, f of 0 equal din yan sa 0. So, ibig sabihin, nag-exist yung ating, yung third, nako-comply niya pero sa positive dito sa right hand. Okay. In this case, masasabi natin na merong yung tinatawag na right hand continuity, no? Yung ating function kasi dun sa x na negative or from the left, hindi siya nag-exist. Okay? So, ganun siya. Okay? Yun yung isa pang example na pwede nating magamit to explain ano ba yung tinatawag nating continuity. Okay? So, ibig sabihin yan yung ating function f of x is equal to the square root of x, okay, has right-handed continuity at x equal to 0. Okay? So, ang continuity, it implies both right hand and the left side continuity. Since ang concern lang naman natin dito is the single valued na na function or yeah, yung existence ng left and right, it implies ordinary continuity lang at that particular point. Kaya kung yung isa, yung left, hindi mag-exist, hindi siya nag-exist, pero sa right, meron siyang value. Kung saang side siya na merong continuity, doon natin siya i-declare. Okay? So, yan. So, i-discuss naman natin yung tatlong conditions, no, para mas ma-appreciate ninyo para saan ba yung mga yan. Okay? So, yung first condition natin dyan kasi dapat daw yung limit ng f of x as x approaches the value c, mag-exist siya. Mag-exist. No? Paano kung itong particular na to, yung limit does not exist? Paano kung mag-fail siya? Okay? Pwede naman siya, no? Pwede namang hindi mag-exist yung ating limit kahit na may value yung ating function. Doon sa discussion natin ng limits, di ba? Palagi ko siyang binibigyan ng emphasis na walang kinalaman yung value or yung existence or non-existence ng value ng function sa existence and non-existence ng limit ng function na yun. Okay? So, isang example natin yan is kung mapapansin nyo itong ating graph dito. No? So, meron tayong curve na ganito yung itsura. Tapos, meron siyang talon. No? May butas, tapos nandito na yung susunod. Sa baba. Okay? So, yan yung ating sample graph. So, ito ay isang senaryo na kung saan yung ating limit of f of x does not exist kasi again, pag-usapan natin yan last time. Meron tayong dalawang value or yung ating left hand is not equal dun sa right hand. No? So, dito, kahit na meron tayong f of c, may chance pa rin na mag-fail yung ating limit or mag-fail to exist yung ating limit pagka ganito yung itsura ng ating graph. So, isa yun sa mga example ng yung limit natin that fails to exist. Kaya naman, importante ng right hand and left-handed na mga limits sa pagkuha ng limits. Okay? So, for example, Hanapin natin yung approximate value ng limit as x approaches 1 from the left. So kung from the left yan, or yung left hand side, so as x approaches -1, yung ating y naman is papunta naman ng +1, no? So yun yung ating left hand. Pero pag right hand naman yung ating titignan, as x approaches from the right, papunta sa 1, yung ating value is no pupunta sa 3. So dahil magkaiba yung ating left hand at yung ating right hand, the limit does not exist. So na-violate niya or hindi niya na-satisfy yung ating first condition. Okay? So masasabi natin that the function or given function is discontinuous. Discontinuous at x equal to +1. So ganyan lang siya. Okay? Next. Yung second condition naman, let's say, for example, yung limit or yung condition number 1 na satisfy. Ibig sabihin, merong limit yung ating function. Pero paano naman kung yung ating function value hindi siya nag-exist? No? Kumbaga, yung second component nitong ating continuity failed siya. Ang itsura niyan is ganito. So let's say dito continuous siya. Continuous hanggang dito. Pero hindi ito yung function value niya. Let's say ang function value niya is ganito, nandito. Let's say f of c is equal to 0. Ganyan. Hindi siya yan. Pero yung graph niya, from the left hanggang dito sa c na yan, or f of -2, no? F of -2, that's f of c rin. Then, pag right hand naman, ganun din. So, iisa yung ating limit, tama? Limit ng f of x as x approaches -2, or +2, sorry. 2. Nag-exist siya. Pero, yung function value naman, wala doon. No? Nandito siya. So, ganun pa rin. Hindi pa rin magkakaroon ng hole dun sa ating graph. Kumbaga, yung left and right hand limits, yes, pareha sila. Although, let me stress this statement that the limit can exist even without the function value existing. Ibig sabihin, yung limit ng function nandito, kahit na yung ating function value, wala siya doon. So, nangyayari talaga siya. In this case, this particular function is discontinuous at x equal to 2. Okay? So, ganun siya ha. So, pagka-graph, medyo madaling i-identify kung yung ating function is continuous or discontinuous or kung nasan yung discontinuity. Katulad nitong isang example natin dito. Yan, no? Katulad nito. Yan. Kahit na yung ating left hand side at yung ating right will both approach yung value nito. No? Pero wala dyan yung sagot or yung function value. Discontinuous pa rin siya. Okay? At this particular point. di ba? Ito naman, ito yung kanina, no? Yung example natin kanina. The limit does not exist. Ito yung condition 1, no? Yan. At ito rin, ito ay mga condition 1 yan. So, in this case, the function value fails to exist. Ito yung ganito itsura niya. Okay? Next. So, paano naman kung yung limit hindi magparehas dun sa ating uh, function value? Okay? Pares din ng example natin kanina is that, yes, meron tayong uh, left meron tayong left hand and right hand na limits which is nandito, no? Pero hindi naman siya equal dun sa f of c. Ito yung ating f of c. Ito naman yung ating limit. So pagka ganyan, hindi natin nasasatisfy yung ating function or yung ating component, kaya masasabi natin na discontinuous at x equal to a. So, ganun lang siya. Ha? Ganun lang siya tignan. Importante yung tatlong component masatisfy natin. Okay? So, let us try to discuss itong example natin na to. Okay? So, let us determine whether this function f of x uh, is continuous at x is equal to 0. Okay? Kung hindi siya continuous, paliwanag natin kung bakit. So, dito sa function na to, ang ibig sabihin lang yan, ito yung magiging function niya, 2x minus 1, para sa lahat ng x less than 0. 3 naman siya basta x is equal to 0. Tapos 3 square root of x minus 1 para sa lahat ng x na greater than 0. So, basic naman siya, no? So, pagka 0 yung x mo, nasa 3 siya. Pagka less than 0, meron siya parang line dyan. Kasi parang ganon. Ganyan siya. Line. Tapos, square root naman. Pag more than 0, square root. Square root of 10. Square root of 100. Parang ganyan. Okay? Sample lang naman yan. So, pagka ganyan yung example natin, sabi kasi dyan, for all values of x is less than 0, gagamitin natin yung 2x minus 1. So, we will find the limit as x approaches 0 from the left of 2x minus 1. No? And of course, it is equal to negative 1. So, nag-exist yung ating limit, right? Nag-exist yung limit. Tapos, f of 0, it is equal to 2 times 0 minus 1, which is equal to negative 1. Okay? Then, ang sabi, if f is equal to 0 naman, no? Ang value ng function ay equal yan sa 3 dahil if x is equal to 0, f of 0 is equal to 3. Yes, meron tayong value sa condition number 2, f of c exists. No? But, yung ating limit, yung limit natin, no, ng 2x minus 1 is not equal sa f of 0. Kasi dito ang value niya 3, tapos ito naman negative 1. Therefore, na hindi na satisfied tong ating condition. Okay? Kaya, yung ating example dyan is not continuous. Okay? Not continuous. Or discontinuous. Okay? So, ganun lang siya i-check Importante yung tatlong component natin, tatandaan nyo palagi yan. Okay? Yan. So we will end this part of our lesson for you to try and solve kung continuous or discontinuous yung mga functions. Okay? So babalik tayo mamaya to discuss more on continuity. Okay? Maraming salamat. See you sa next part ng ating lesson.